Hello everyone, welcome to New Wave Coaching Classes for Science. This is your host Jatin. Today we are going to carry forward our lecture of acid, bases and salt with the topic of salts. Right, dear students, we have already discussed about the acid and bases, the pH of the acid and bases and many other things in our previous lectures. Today we are going to discuss about the salts, and most probably this will be the last lecture of this topic, right? So let's start without wasting the time. So first let's understand what are basically the salts. You must remember that we have discussed about a neutralization reaction between acids and bases. Basically, what was the reaction? That acid and a base react with each other to form some neutral substances, and one of the neutral substances from them is a salt, right? Now let's understand what is basically a salt. What is the definition of a salt? Salts are ionic compounds formed by the combination of a cation from a base and an ion from an acid. I repeat myself. Salts are ionic compounds formed by the combination of cation from the base and an ion from an acid. Now, what does an ionic compound means? It means it contains ions, right? It's formed of ions, right? So let's take an example. They are formed. Now, when they are formed when an acid and a base neutralize each other. This is what I have discussed previously also in the neutralization reaction, that when an acid and base react with each other, they form neutral substances. That is why the reaction is called a neutralization reaction. So one of the product formed in neutralization reaction is a salt, right? And we have an example also. You can see NaOH, that's the base, sodium hydroxide, plus HCl is an acid, hydrochloric acid. They both react with each other, and what they are forming two neutral substances. One is NaCl, that is sodium chloride, and the other is water. And this, when we talk about NaCl, this is the most common salt which we use. This one. NaCl is the most common salt, that is why it is also called as common salt. And this is one of the salt. If it is not present in our food, then the food is not tasty, right? So this is required. Now the next thing that comes is about naming of a salt. Now how we name a salt? The first part comes from the name of a metal. Whenever we write the name of a salt, the first part of that name comes from the name of the metal of the base used, right? When you talk about the name of this salt, this is sodium chloride. Now the first part is sodium, and sodium, you say the name of the metal. Sodium is a metal. That part is coming from the base. So this is the base I have used. So in it, its first part is sodium. So the first part of the salt comes from the metal name of the base, right? The second part comes from the anion of the acid that was used. Second part comes from the anion. Now it is sodium. The first part comes from the base, chloride, sodium chloride, and the chloride comes from the anion used in the acid. And this is hydrogen chloride, or you can also say hydrochloric acid. So this chlorine or the chloride ion name is added up here. So this is how we name a salt, right? Now the next thing that comes in the series of salt is the family of salts. Now you must be thinking, what is about family of salts? But salts also have families. Salts having the same positive or negative radical belongs to same family. I repeat, salts having the same positive or negative radical belongs to the same family. Now let's take an example. You will see the first part of the example is given NaCl, that is sodium chloride, Na2SO4, that is sodium sulfate, NaBr, that is sodium bromide, and then I have written Na2CO3, that is sodium carbonate. Now if you see the beginning, the naming of all the four, the salts which I have written, the beginning is all having the first letter, the first name of all the salt is sodium. So we say these all salts and many more belongs to the family of sodium salts which begin with the name sodium, right? Next, I have written NaCl, sodium chloride, KCl, that is potassium chloride, CaCl2, that is calcium chloride, MgCl2, that is magnesium chloride, AlCl3, aluminum chloride, belongs to family of chloride salts. Why? Because the second part of all these salts is same, and that is chloride. So this is why we say that these all belong to the family of chloride salts. So this is how we have the family of salts. So if the first name is same, we tell that the salts belong to that family, and if the second part is same, then we say that the salts belong to the other family, right? The next thing that comes in the series of the salts topic is about pH of salts, right? So let's take about the pH of salts. Alright, when we talk about the pH of the salts, you have learned about pH also in the previous topics. pH is basically we use to find the strength of any solution. If pH is less than 7, we say the solution is acidic. If pH is more than 7, we say the solution is basic. And if it is equal to 7, we say the solution is neutral. So same way, we can also find the pH of salts also. How we can find? We can do the hydrolysis of salt. We can put the salt in the water and then we can find the pH. And we have 3 cases. Now, why these 3 cases arises? Let's see now. In the first case, we can have salts which can be acidic. Although you have learned that when an acid and base react, it's a neutralization reaction. The salt and the water which are formed are both neutral. But sometimes what happens? Let's see the first case. What happens in that case? When a strong acid reacts with a weak base. Now, the strong acid is able to give large number of hydrogen ions, but the weak base is not able to give that much number of you can say hydroxide ions, which can completely neutralize those hydrogen ions, right? So what happens in the salt? Since there are more hydrogen ions left, so the property of salt becomes acidic, right? So we have an example. Here we have HCl. You see, HCl is a strong acid. This is a strong acid. This is a strong acid. And this is the weak base. Ammonium hydroxide. So when they react with each other, what the salt form is ammonium chloride. Now, since the HCl was stronger, in terms it can give more number of hydrogen ions, that is why the salt form here is an acidic salt. Right? So acidic salts will be having the pH less than 7. It will not be much less, you can say it could be around 6, 5.5, not less than that. So they're not very strong actually, right? Then we can also have basic salts where the pH is more than 7. So we say bases which pH is between 7 and 14. Now why this case arises? When a strong base reacts with a weak acid. Now in this case what happens? The strong base is able to give a large number of hydroxide ions, but the weak acid is not able to give that much of hydrogen ions which can neutralize or which can combine with our hydroxide ions. So due to that, what happens? More number of hydroxide ions are left in the solution, and because of which the property of the salt becomes basic. So we have an example. This is hydrogen carbonate, or we also say it as carbonic acid. This is a carbonic acid, and carbonic acid is basically a weak acid. And this carbonic acid is also present in your soft drinks. Right? This carbonic acid is also present in the soft drink. That is why we are able to drink them, because it's a weak acid. Although it creates some problem in our body also. We should not consume much of the soft drinks. Right? And this is NaOH, it's a strong base, sodium hydroxide. This is strong. So what happens when they both react with each other? This hydrogen carbonate or the carbonic acid is not able to completely neutralize sodium hydroxide, and due to the presence of excess number of hydroxide ions, the salt which is formed, that is sodium carbonate, is a basic salt. So this is a basic salt. Right? Now the third case which arises, as I said, we can have three kinds of solution. We can have acidic, we can have basic, and we can have neutral substances also. So the third case that comes is about neutral salts, where the pH is equal to 7. Now what happens in this case? When a strong base reacts with a strong acid. Now what happens in this case? The acid also and the base also both are able to give almost equal amount of the ions, that is hydrogen ions from the acids and the hydroxide ions from the base, and they are able to neutralize each other, and whatever the salt formed is having a pH equal to 7. So when I give an example, HCl is a strong acid, sodium oxide, sodium hydroxide is a strong base. When they both react, what they form is sodium chloride, that is a neutral salt, and water again a neutral substance, right? So this sodium chloride also we use in our food also, right? Now many of you must be thinking there can be one more case. What more case can be there? You see strong acid, weak base, strong base, weak acid, both are strong. We can have one more case. The fourth case can be when a weak acid reacts with a weak base. Now when a weak acid reacts with a weak base, whatever the salt formed can have all the three properties. Whatever the salt is formed here, this salt can have all the three properties. It can be acidic, it can be basic, and it can even be a neutral salt. And that will all depend upon which ion is more in number. If the number of hydrogen ions are more, it could be slightly acid. The weak acid is giving little bit more number of hydrogen ions, so the salt can be slightly acidic. And if the weak base is given more number of hydroxide ions, then the salt can be slightly basic. But if they are equal, then the salt will be formed. That will be a neutral salt, right? So this was about the pH of salt. Now the next topic that we are going to study is about sodium chloride. That we can get many chemicals from the sodium chlorides, right? And sodium chloride is a common salt. One of the things about sodium chloride is that we require this for the food we eat, otherwise the food doesn't become tasty, right? So now let's discuss about what are the chemicals which we can get from this common salt. Now the first salt which is formed, which we get from the sodium chloride is sodium hydroxide. Now the first thing which we should know is how it is formed, right? Now how it is formed by the electrolysis of brine. This. Now what actually this brine is? The aqueous solution of sodium chloride, that is the common salt. Aqueous solution of sodium chloride is called as brine. And electrolysis means we are passing current through it by putting some electrodes, right? So when current is passed through the aqueous solution of sodium chloride, which is also called as brine, now we get three things. The first thing we get is sodium hydroxide, then we get chlorine and hydrogen gases, which are collected on the different electrode. Now chlorine is collected on the anode and hydrogen is collected on the cathode. Now we are getting three important things. And this process is also called as chlor-alkali process. Now the question, there's a question which comes in the exam, why this process is called as chlor-alkali process. Now if you see the first letter, chlor. This chlor comes from chlorine. And this alkali, this sodium hydroxide is basically alkali. So this alkali is this. Right? So that is why this is called as chlor-alkali process, due to the formation of chlorine and alkali sodium hydroxide. Now all of these three compounds which are formed, out of the three compounds which are formed, have their own uses. And what are the uses they have? If we talk about sodium hydroxide is used in degreasing of metals. It is also used in formation of soaps and detergents, and is also used in paper making, right? When we talk about chlorine, it is used in the treatment of water. Chlorination, you must have studied about this thing. Then formation of PVC pipes, right? That is also called as polyvinyl chloride. Then CFCs, which are also called as chlorofluorocarbons, and also in the formation of many pesticides, right? Then when we talk about hydrogen is used as a fuel mostly. Then also it is used in the manufacture of ammonia, and ammonia is used in the formation of fertilizers. Now this is their individual uses. When we combine them, we see hydrogen and chlorine. When they combine, they form hydrogen chloride. And the use of hydrogen chloride is cleaning steels. It is also used in the formation of ammonium chloride. Many medicines which contains hydrochloric acid, and in many cosmetics also. When we combine this sodium hydroxide and chlorine, it forms bleach, right? It forms bleach. It helps in the formation of bleach, which is our next compound in the series of the raw materials which we get from the common salt, right? Alright, we go to the next chemical in this series. The next chemical that comes is bleaching powder. Bleaching powder, the chemical formula is CaOCl2, and the chemical name is calcium oxychloride. And how it is produced, let's see first this thing. We have seen in the previous example, we can say reaction, that chlorine was evolved during the formation of sodium hydroxide, during the electrolysis of brine. So that chlorine is also used, as we discussed previously, that chlorine and sodium hydroxide combined together, they are used for bleach. And chlorine is also used for the production of bleaching powder. And how it is formed, let's see. Chlorine produced during the electrolysis of brine is used in the manufacture of bleaching powders. It is produced by the action of chlorine on dry slate lime. It is also called as calcium hydroxide. So it's in the dry form, and in the dry form, when chlorine is passed over it, we get CaOCl2, and the chemical name is calcium oxychloride. Right? So this is the chemical name, calcium oxychloride, and along with it, water is formed. Now, bleaching powder is used at many places. Let's see some of its uses. First, for bleaching cotton and linen in the textile industry, for bleaching wood pulp in the paper factory, then for bleaching wash clothes in the laundries, as an oxidizing agent. Also it is used to oxidize many substances, because this oxygen is quite loosely bonded with it. So when it is used, it loses oxygen very fast and oxidizes the other substance. And also for disinfecting drinking water. Like chlorine, bleaching powder is also used for disinfectant, for cleaning the drinking water, right? And now the next thing that comes is baking soda, the next chemical. The chemical formula is NaHCO3, and the chemical name is sodium hydrogen carbonate, or we also call it as sodium bicarbonate, right? And it's a very common, so this is also very common, you can say, ingredient in our home, in our kitchen, like a common salt. Baking soda is basically used in the kitchen for faster cooking, right? And how it is produced? See, again, sodium chloride is one of the raw materials in the production of baking soda. Now, sodium chloride along with water, that is the, you can say, the solution of NaCl in water, plus CO2 and plus ammonia, when they all combine, they form ammonium chloride and NaHCO3. And when you talk about NaHCO3, sodium hydrogen carbonate or sodium bicarbonate, it's a basic salt. It's a basic salt. You remember when we studied about the importance of pH in our daily life, we studied one thing, then during indigestion in our body, due to the excess, we can say, excess eating, some more acid is produced in our body, because of which there is some burning sensation in our chest. So during that, what we can do, we can put this baking soda in water, we just make a solution and just drink it, and it will give relief. Why? Because it's a basic salt, so it neutralizes the acid which is formed during that process, right? Now also, when now the question comes, how it helps in faster cooking, right? So let's see, when during cooking, when baking soda is heated, what happens to it? When it is heated during cooking, then following reaction takes place. What kind of reaction takes place? The sodium hydrogen carbonates, when heated, forms Na2CO3 plus water and plus CO2. Now, this CO2 is important here. Why? Because when you were in grade 9, you must have learned about the greenhouse effect. And one of the main gas is of the greenhouse is carbon dioxide gas, right? And what CO2 does? CO2 does has a very important property that it absorbs heat energy and increases the temperature. Same thing it does during cooking also, right? So this CO2, when it is formed during the heating of NaHCO3, this CO2 helps in cooking the substance faster because more heat is absorbed during this, right? Now, what are the uses of baking soda? In making baking powder, and baking powder is a very important ingredient in forming the cakes and the breads. Why it's a very important ingredient? Because again, CO2 is produced, and CO2 helps in making the cake fluffy, and right. And also it is used in antacid, as I said. During indigestion we can use it, and also in the soda acid fire extinguishers. So this was the fire extinguishers which we used earlier, in which along with HCl this baking soda was used, right? And when they reacted, carbon dioxide gas was produced, which was used to extinguish the fire, right? So let's see the next topic now. Now the next one in series of these compound which we are getting from sodium chloride, the next thing that comes is washing soda. And by the name we can tell the washing soda is basically a soda used for washing. The chemical formula Na2CO3.10H2O. You must be thinking, what is this 10H2O? This dot a little bit brighter, so that's visible to you. So let me put it here also. I hope it's clear with everyone, right? That there is a dot. So what is this 10H2O with Na2CO3? We'll discuss about this water molecules which are attached with this sodium carbonate at the end when we complete the topic, right? So first let's understand how this is formed. Now when we previously discussed about baking soda, we have seen when baking soda is heated, Na2CO3 is formed, that is sodium carbonate is formed, and recrystallization of sodium carbonate is formed by heating baking soda, and recrystallization of sodium carbonate gives washing soda, and this washing soda is also a basic salt. So this is what happens when the salts turns into crystals. Some water molecules attached with them, right? And what are they called? That we will discuss again at the end of the chapter. Alright, now what are the uses of washing soda? Used in the glass, soap and paper industries. Used in manufacture of sodium compounds like borax, can be used as a cleaning agent as the name suggests, and again used in removing permanent hardness of water, right? Now the next thing that comes is plaster of Paris. You must have heard about plaster of Paris a lot of time, because it is one of the compound which is used by the doctors to set up the fractured bones, right? So POP is used there. The formula is CaSO4.12H2O. Chemical name is calcium sulfate hemihydrate, right? It's calcium sulfate hemihydrate. Now how it is formed? On heating gypsum at 373 Kelvin, that is about 100 degrees Celsius, it loses some water molecules and becomes calcium sulfate hemihydrate. Now this is the reaction. CaSO4.2H2O when heated at 373 Kelvin form CaSO4.12H2O plus 1.5H2O is removed. Now what happens? Now this calcium sulfate hemihydrate, that is POP, is a kind of white powder, right? And now when this POP mixes with water, it turns back to gypsum again. Yeah, now you must be thinking one thing, how we can have half molecule, right? Well, we don't have a half molecule. What actually happens here? Let's see. What happens? The two molecules of calcium sulfate are basically attached to one molecule of water, right? So when we take one molecule, so by proportion it becomes half, right? So actually it is two molecules of calcium sulfate which are linked with, or we can say with which one molecule of water is attached. Now the question, this was the last thing of this chapter. Now as I said, water. What is this water? This water is called basically water of crystallization. These water molecules which are attached with the salts is called as water of crystallization. Right, now what is this water of crystallization? Well, as I said, when the salt turns into crystals, when the crystals of salt are formed, some water molecules get attached with them, due to which this thing happens. Now we can do one experiment also. What experiment we can do? There are many more substances. One of the substances we talk about, calcium sulfate. This is the formula: calcium sulfate dot 5 H2O, CaSO4.5 H2O, and in common terminology it is also called as blue vitriol. Right? This copper sulfate is basically a blue colored salt. Right? Now what happens when we put this salt in a test tube? We put this salt in a test tube. This is a blue color, and hit it at the bottom, from the bottom. Now what happens? Initially the salt color turns into white. Now why this happens? Why the blue color changes into white? Because these water molecules, due to a little bit of heat, gets removed from the salt and the salt turns white. But as soon as the heat is removed, the water molecules come back, the salt again turns blue. So this thing happens in case of water crystallization. These salts are not actually, you can say, wet, but there are some crystals of the salt which are formed, right? So, right, dear friends, this was all about the salts and the different compounds which we can get from the sodium chloride, as we discussed, and about the water crystallization. So, hope you understood everything. If not, then watch the video again. Make sure to like the video and subscribe to my channel. And this is from my side. Goodbye and take care.